Hi everyone, welcome back to my channel. Today I want to share some tricks I used in production timeline. I'm going to add this scene file in the link in the description below. Feel free to download it and you can inspect this file. I hope this file will help you. Let me know in the comments below if you learn something from it. Subscribe to this channel, like this video, and share it with your friends if you feel this content is helpful. It's really helpful because sometimes we want to merge all the VDBs before sending it to some Arnold render or RenderMan, and because Light may not want everything separated, so you may want to combine all the VDBs in center Light. But when you combine all the VDBs, you might have faced something like you have multiple densities, multiple velocity fields in your volume, and most of the renderers don't pick up multiple densities and multiple velocities in one single object. They all have to be combined together. If not, you have to give them individual objects for the render. For something like this, it's cool. It's just like five pyros. I can just individually give 5 different objects. But if it's something like 100 different VDBs, 100 different smoke sims across the whole environment, and if Light asked you to give all of them together, it's gonna be like a bit tricky. You need to combine your VDBs. So I have 2 different ways of combining VDBs, and I will also show you why I also have this complicated way of combining VDB. First, I want to start with my explosion sims. These are just like single add point, and I just have a pyro burst source. Where is this? Yep, same pyro burst source, and then I just changed it to volume, and I just have like basic sim with pyro soap solver, and I caged it out. So this is how it looks, and I have the similar things for others as well, and I combine all of them together now. So the first and most easiest way to do is you can just drop a VDB combine and get and pick density here and make the collation the operation method to flatten all A and make this add. And what it will do is it will, like, if you see the geometry spreadsheet, now here all the densities and velocities, like you have 5 different types of densities and 5 different types of velocities, and as soon as you did VDB combine the densities, all the densities match together. Even if you can see the box, guiding bounding box on the viewport, and the same thing happens to the velocity as well, and this works. And if you check this now, if you take out this, all of the density, all of the velocity got matched together, and it works most of the times. But sometimes if you have like something like this happened to me once. I have like so many volume sims across the environment, and Soup wants me to have different density variations across the environment, like of all the volumes, and that's when this method comes in handy. This is very simple. This looks very complicated, but this is very simple. What I did was I just created a null, and I named it all volumes, and I used a split node, and in split I split the density. So one side of my split has only density, one side of my split has only velocity. So now when it's like this, it's more easier. If you have all of them together, doing this for each loop would be very hard. If you combine all of them together, it's more easier. So I got all of them here, then I put all of them into a for each loop, and I want it to run by the count, not by number of pieces, because if I make it number of pieces, and it might get you use the name attribute, because for all of them the name attribute is density, it may not work as we actually thought. We actually may be able to change the name for each thing and then again use the for each loop, but that gets complicated. So just for that I used count to get the number of like volumes. I just used n prims. It gives total number of primitives, and I use this all density null to calculate how many densities are there here, and it will calculate those many and you will do iteration those many times. And the first input is I'm just fetching the input, and like normally if you already used for each loop before, you know this, that you can create meta import node using here, and this will store all the data like which iteration is running, how many iterations, all these things in detail attribute, which we can use so many times, and it's really helpful. So that's what I did. Just for organization purpose, I created a null and I named it iteration data, and I got a blast node. I added spare input using this, and I got this iteration data into spare input, so I can use it as -1. So here now I know this detail attribute has like the iteration number. For example, if it's the first iteration, this will be 1. If it's the second iteration, it will be 2. If it's the third iteration, it will be 3. Sorry, if it's first iteration, it will be 0. If it's second iteration, it will be 1. If it's third iteration, it will be 2. So it will, so now you know which iteration will be going on. So what I do is I blast everything except the current iteration, and I know this detail attribute has all the information, and now I blasted everything except the current iteration. And if you check that, see, this is the current iteration like you, and then this is the feedback. So what is feedback? So whatever we are doing here, for example, here we have the method feedback each iteration. So what it's doing is, it's whatever we are doing it, that's what it's outputting here. If we want another method, we have something called merge each iteration. If you do that, it will merge every time it does something, it will merge with the old output. So we don't want that because we are already using VDB combine. That's what we are using this for. So I did feedback each iteration, and this feedback I got it here. So this for each feedback is getting what happened after the first iteration, then it's combining with the second iteration which is blasting, and then I'm combining all of them together, and I'm doing the same thing with the velocity as well, and I'm merging together. Now if you look at, I just have one density and one velocity, and all the results will be happy. The biggest reason why I want to do it is, for example, if I want to have random density, it's easier for me. Now I can just get this. Now I know the second input has the detail attribute, so I will be like, I will just get iter and detail 1 iteration 0 and now I will create random. It'll also create a seed float seed to chf seed random idea of seed. Sorry. And I can fit it in between min and max. And I can finally multiply this with my density. 0.1 and 1. See, now it 0.5. So now it randomly multiplied density based on the iteration number and have like different seeds. So we can do so many cool things like this. So if you are doing VDB combine across a lot of big area and so many iterations, I would definitely prefer this method. I will add this scene file in the description below. Feel free to download it and have a look at it. And I hope you like this video. If you like this video, please like this channel, subscribe to this channel, and share this channel with your friends. And I hope you will enjoy this content, and I hope you will learn more. See you soon.